Thanks for tuning into this session. Are you developing an application where you're protecting audio or video content? Hi, I'm Tim Rule, and I work on content protection at Microsoft. We have a solution called Microsoft PlayReady, which is now built into the Windows 10 runtime. This allows you to develop solutions that protect audio and video assets directly within the platform. So what is PlayReady? PlayReady is a set of technologies designed to protect content for delivery over the internet. What does it target? So mainly it's used for premium movie services, but it can also be used for other things such as enterprise video or even a video sharing application, whenever you want to reach a higher security bar for that content. So depending on the scenario, you will configure PlayReady via a set of license policies to fit that target solution. For example, let's say you're developing a rental scenario. You would configure your license policies to set time-based settings such as an expiration date. Now, what's new with PlayReady on Windows 10? Well, PlayReady 3 was introduced in the last year, and one of the main features is the support for hardware-based DRM. What that does is provide a much higher level of content protection, as well as the decryption and decoding happening on the hardware in a dedicated fashion can provide much better performance, as well as increasing your battery life for your device. So what are the main components when you're developing a solution? So I'm putting them in three big buckets. One is the content packaging and encryption, and this is where you take a media file and you encrypt the audio and video components within that file. And then you can use it to deliver over the internet in a variety of ways. Nowadays, it's commonly delivered using an adaptive streaming technology such as MPEG-Dash. There are several encoders, and many of the top encoders will understand how to provide PlayReady protection to your assets. Another option that they provide is using common encryption. And with common encryption, things are protected in such a way that different key systems can be used to access that content. So you might use PlayReady on one platform and you might use a different key management system on a different platform. The next part would be developing your license services. So a license service is what a client will use to request a playback license. Now this is developed using the PlayReady Server SDK, and if you don't want to build your own, there's a lot of application service providers that provide solutions around this, such as license services, as well as end-to-end video service and client options. Lastly, you need to build a PlayReady client, which is the focus of this presentation, primarily targeting Windows 10. So when you build an application, you're going to be pointing to this protected content for delivery, and then you're going to use a license service to get playback license for that content. So when you're developing an application on Windows 10, you have two options. One, you can develop your application using the Universal Windows Runtime, and that will work across all supported languages such as JavaScript, C# and C++. These are APIs that are built right into the platform. Second, you can use encrypted media extensions if you're developing a JavaScript application. The reason you might want to do this is maybe you have a web-based premium video service and you want to create a Windows application from that service. With encrypted media extensions, you can use a standards-based approach of doing protected playback and be able to share the same code base you have for your Windows application as you have for your web-based application. Now we're going to look at the first mode in this presentation. So what this looks like in a workflow is you create a media protection manager object, and then you wire that object properties to understand PlayReady on the platform. Once you do that, you assign it to the media element, which is the playback component for your application. After this is set, when you begin consuming protected content, it will know how to manage it, and it'll work through the protection manager to make a license, or to determine whether PlayReady can consume that content or if it needs to request a license. Now, if this is the first time your application has run, it'll also go through an individualization service. An individualization service is an external service that your application will call out to, which will prepare your application for DRM, such as configuring the license storage mechanism, and as well as preparing the PlayReady components. Once this happens, and it should only happen once unless an app is uninstalled and reinstalled, or in some rare cases there might be an OS update that updates the security components and requires re-individualization. But once this happens, the PlayReady can then make a request for a license. It'll do that by working through the protection manager, which will send that request on its behalf. Once that license service authenticates that request and decides to deliver a license, the application can then consume that license, and then you can do playback. So what does that look like from a code perspective? Let's jump over to Visual Studio and we'll go through that same workflow via code. So we have a simple application here with a play and stop button, as well as a media element, and then additionally we have a list view control, which we're going to use to log various messages to the screen. I've also set up the application to uninstall and then reinstall. In doing so, we can test, it'll force the application to re-individualize every time it runs. This is useful to test out the individualization process, and it is useful if you want to put messaging around that, such as if the user tries to call that service and they're offline, then that will, you'll be able to trap that exception and then present a friendly message to the user. So later on, when I've completed that development, I more than likely would uncheck this to speed up the build process. When we're looking at our source code, here we create that media protection object and we assign a series of properties. Now these properties likely would not change. What they're basically doing is mapping PlayReady on the platform via its specified protection system ID. And as mentioned, you would not change these values, but they need to be set initially within your application. Next, we're going to configure two event handlers. The first is the component load failed. Now, this event would fire if there was some problem with the security components. Likely, this would be a pending operating system update that is affected by those components. It's good to trap that exception and then be able to prompt your user to apply pending updates, or possibly maybe your reinstall an updated version of the application. Next is the service requested call. Now the service requested is where all the messages from PlayReady are going to be sent and processed and relayed by your protection manager. And that's what we're doing right here. The one thing we're doing prior to calling the specific service request is we're configuring a completion notifier. This allows us to track the process of the status of the current service call, and in some cases we might have a second service call that happens after it, and this allows us to track its completion and then call the second one. Now for our scenario, we're just doing those two mentioned service calls, one for individualization and one for license acquisition. There's a series of others that do different things for more complex scenarios, such as if you're supporting PlayReady domains or you're implementing a secure stop service, which allows you to more accurately manage concurrent streams under a particular account. Now, the actual call for the individualization service is begin service request. Every single one of those PlayReady service calls will have the same method. In this case, once this asynchronous call completes, we will log the security version as well as the the security level. If it reports as 2000, that's using software-based DRM. If it reports as 3000, the device is using hardware DRM. We're doing a similar thing for the license acquisition, where we're doing the begin service request. The only other thing we're doing other than just calling the service request is overriding where the application is looking for a license. And this is a common practice where you might want to point to a different license service depending on what environment you're running within. For example, in a staging environment, you might use a different license service. In this case, I'm using a different one because I'm using our configurable test handler so I can test out different license policies. So if we run this, as long as I have connectivity, and it looks like I do, I should be able to see the individualization service fire. It's calling it now, and then when it completes, it's going to call the license acquisition service. And it should begin playing back the content as well. Now, one thing to note here, it reported a security version, and this is a number that would likely be revved if there is a future security update. It also noted that the security level for this device is 3000. That means this machine is using hardware-based DRM and can take advantage of that hardware-based decoding and decryption, which we mentioned earlier. So what happened there is when the user clicked the button, we set the media source to a dash asset, and as of Windows 10, support for dash is built into the platform, and it automatically triggered a request for a license down through the DRM, which triggered the individualization, which, when that succeeded, triggered the license acquisition request. Now, the second way of doing this is to proactively call these service requests. In some cases, that might help us better manage the user experience. For example, maybe you have a video rental or purchase scenario where you want to individualize and request a license for a piece of content prior to even downloading that content. So here we have two methods, proactive individualization and proactive license acquisition, and each one is respectively calling those other methods that were defined above. For the proactive license acquisition, it does take in a key ID to help us determine which piece of content we're getting a license for. Now, let's find a place to call these two methods. For the individualization, what we're going to do is go to the end of our constructor, and we'll check to see if the security version is available. I know that this checking that for that security version will throw an exception if the device has not been individualized. We're going to take advantage of knowing that to check that security version and then call individualization if that security version is not found. Now for the playback, we'll go into here and we'll add a button to request a license directly. We'll go in here and we'll actually wire up that button event. And what that's going to do is call that license acquisition proactively, and I'm passing in a key ID, which I know refers to the key ID used for that piece of content we were testing earlier. So now when I run this, the first thing we should see is that license acquisition, which is being directly called. So there we're seeing it's reporting as unknown, and then here it's called it proactively, and it's reporting SL3000, security level 3000. Now I'm going to call get license, and we have a license. So now I hit play, it'll play back the content, and you see it's not requesting a second license. If I was to go back into that deployment configuration and uncheck that button that uninstalls and reinstalls the app, when this starts up again, we will get playback without any service calls because we already have persisted a license on the device and the device has already been individualized. So where do you go from here? On MSDN, there's a PlayReady Universal Sample that provides much more detailed demonstrations of the technology, and it covers basically all the PlayReady APIs that are available. In addition, there's a variety of test vectors that test different adaptive streaming technologies such as Dash and Smooth, as well as different video codecs such as H.264, H.265, and possibly some others. Maybe some VC1 content as well. The project actually contains, the solution actually contains 3 separate projects. The first 2 are a C# and a JavaScript app that support the PlayReady through the Universal Windows runtime. And then there's a third JavaScript sample that shows how to do PlayReady via the W3C's encrypted media extensions. Now, speaking of those, let's briefly look at the workflow for encrypted media extensions and see how similar it is to the workflow we just experienced. In this case, when protected content is delivered to a Universal Windows platform app using EME, or whether it's Edge or IE browser on Windows 10, if you've configured the video tag to understand the key system, the PlayReady key system, and there's samples of that. There's a good one on the IE test drive site for, or I'm sorry, the Microsoft Edge test drive site. Can I redo this slide?
Yeah, go ahead.
Sorry. I shouldn't have mentioned IE. Now let's look at how PlayReady works within an encrypted media extension scenario for a Universal Windows app. You'll see that it's quite similar to the workflow that we just went through with the Media Protection Manager. The first thing you do is you configure the video tag with the PlayReady protection system. Little different syntax than when we were mapping the Protection Manager, but it's the same type of concept where you're mapping a underlying DRM system to the component. Then when you get protected media, it'll trigger an encrypted event, and that will in turn work through your code to create a key session to request a key or to see if there's a key for that license. And in this case, there is no key, so the underlying DRM will make a key request, which will be relayed via an HTTP request within your application to a license service. Similar to the other workflow, if it's authenticated, the key will be delivered to your application and then applied to the DRM for playback. Now, in this scenario, the key request and delivery, it's the exact same format as in the other scenario, and you have the exact same security components involved. So that means if you're doing it this way, the protocols are the same for the service calls, and you have the same security level, and if you have hardware-based DRM, you're going to get the same benefit regardless of if you're doing it via encrypted media extensions in a Universal Windows platform app, in an Edge browser, you still have the same benefits. So where do you go from here? There's various ways of testing out or exploring the technology. We have a PlayReady test site listed here, and this will give you some content test vectors as well as that license service we used in the example. It'll give you, there's several different parameters to test out various licensing scenarios, such as you may want to test out various output protections. You can test out the secure stop service, PlayReady domains. It's all available to you without needing to set up your own license service. In addition, If you have an Azure account, Azure Media Services provides content protection services, as well as you can set up a PlayReady license service through their portal, and it works very well. And it's a great way to get up and started with testing out an end-to-end scenario. In addition, I use that media element in the sample, which is a very minimalist video playback control. There's a player framework which basically has augmented that media element to support lots of other capabilities, such as supporting captioning. It has a UI for transport controls, supports different ad formats, even supports offline scenarios. Building off of that is a much quicker way to develop an application. In addition, it's provided as all source. You can go in there and make your own changes. Lastly, if you go to the PlayReady website, you'll see all the different PlayReady licensees that provide application services, such as license services and client development, as well as there's a section on feature technology partners, which are different partners we work with that are very active in the PlayReady ecosystem. In this session, we reviewed how to use PlayReady, which is now built into the platform for Windows Universal Apps. In addition, we looked at the source code and showed the basics of how to implement the technology. If you look at the samples as well as test content, you can build off of that knowledge and be able to build really cool applications that support premium content. Thanks you for tuning into this session.